So welcome in this session. This session we are going to show the steps on how to find conjugate harmonic functions. So example 1. Find analytic function f of z given by u plus iv if u is a function 2x into 1 minus y. Let's start with this appetizer. So our solution, f of z analytic implies u and v satisfy CRE. That is partial u partial x equals to partial v partial y and partial u partial y negative partial v partial x. Or this equation can as well be written as partial v partial x equals to partial minus partial u partial y. So let's call this one equation 1, this one equation 2. Our u is the same as 2x minus 2xy. This and this one have the same meaning. So partial u partial x is given by, this will give us 2 minus 2y, partial u partial y will give us minus 2x. So equivalently, this is the same as partial v partial y, and this is the same as minus partial v partial x. So partial u partial y the same as minus partial v partial x. So it tells us that partial v partial x itself will be simply divided through by negative, so we'll have 2x. So call this one equation 3, call this one equation 4. Now we know that from calculus dv equals to partial v partial x dx plus partial v partial y dy. So call this one question 5. So replacing 3 and 4 in 5, we get dv. So partial v partial x is 2x dx plus partial v partial y is 2 minus 2y dy. Call this one equation 6. So to get v, Now integrate. Both sides of equation 6. So that is integral dv integral 2x dx integral of 2 minus 2y dy. Now integral of dv gives us v. So this will give us x squared. This is a constant of integration, but because also we have another constant of integration here, we'll add just at the last step. This will be 2y. This will be y squared, and then plus constant of integration. So therefore, the value of the conjugate function therefore the conjugate function v is v of x comma y is given by x squared plus 2y minus y squared plus c. Example 2, given that u of x comma y is x squared plus, not plus, minus minus y squared minus 2xy minus 2x plus 3y, find its conjugate harmonic function. So here, you need to know that two functions u and v are harmonic conjugates if they satisfy the Cauchy-Riemann equations. So solution, u and v are conjugate harmonic if they satisfy, if and only if they satisfy the Cauchy-Riemann equations, i.e. partial u, partial x equals to partial v, partial y, and partial v, partial x equals to minus partial u, partial y. Or you can write this second one as same thing as saying partial u, partial y equals to negative partial v, partial x. So let's get our partial u, partial x. So partial u, partial x for the function given, which is x squared. So we'll have 2x and then minus 2y and then minus 2. And then partial u, partial y will give us minus 2y and then minus 2x and then plus 3. So this is the same as partial v, partial y, and this is the same as minus partial v, partial x. So from this two, we have partial v partial y equals to 2x minus 2y minus 2. We'll call this one 3. And then partial v partial x. So when you divide through by negative, we'll have 2y plus 2x minus 3. Call this one 4. So whereby I have called this one, call this equation 1, call this one equation 2. Now from calculus, we know that dv is partial v partial x dx plus partial v partial y dy. So we have dv partial v partial x is 2y plus 2x minus 3, and then dx partial v partial y is 2x minus 2y minus 2, and then you put dy. So call this one equation 5. Our interest is to get this, so therefore from this 5, we simply integrate both sides of 5. Now integrate both sides of 5. That is integral of dv equal to the integral of 2y plus 2x minus 3 dx plus integral 2x minus 2y minus 2 dy. So integral of dv is v. This with respect to x will be 2xy. This with respect to x will be x squared. This will be minus 3x. Here will be plus. With respect to y, it will be 2xy. With respect to y is minus y squared, and then minus 2y, then plus constant of integration. But then when you are doing such kind of problems, if we have carried out the integral in these two parts and there are terms which are repeating themselves, then you have to ignore those repetitions. So to get the correct form of v, the correct form of v is when we ignore repeated terms. This is what I mean. That you see, like for this case, this 2xy and 2xy are common. So we'll have to delete one so that the function will be. Therefore, our v of xy will be given by x squared minus 3x minus y squared minus 2y, then plus c. And then we include one of the repeated terms. So remember, when two terms which are repeated, you don't add them together, but you do away with one, and then retain only one of the two terms. So then plus 2xy, then plus c. But this and this were the same, so you delete one and pick one with these other terms which are not repeating themselves. So therefore the equation would be x squared minus y squared, and then minus 3x minus 2y, and then plus 2xy plus c. 1, 2, 3, 4, 5, 6. It has 6 terms. So that's what we're supposed to do. In the next session, we'll also give more examples on the same. Thank you.